Goran is interested in the number of sightings of a particular bird each week in the 50 weeks following the first day of September. He collects some data which is shown in the table. The sample mean number of sightings per week for this data is 1.76. Calculate the unbiased estimate of the population variance of sightings per week. We need to put this into the spreadsheet of a calculator to figure out S sub n minus 1 squared. We put the data into this spreadsheet. A for the data, F for frequency. Go to menu, go to 4, go to 1, stat calculations, 1 variable statistics. Enter. X1 list is A. Frequency list is F. Then enter. We got X bar equals 1.76. For this S sub n minus 1 equals 1.30243. Control Doc to add a calculator. Let's go to variables. We can pull this S sub X out. Then we can square it. We got 1.70. Goran believes that the data follows a Poisson distribution. State why your answer to part A supports Goran's belief. We know in Poisson distribution, mu equals sigma squared equals m. Variance and mean are very similar. One is 1.70, the other is 1.76. Goran decides to test at the 5% significance level to see if his belief is correct. His null hypothesis is X follows Poisson distribution with M, where the random variable X is defined as the number of sightings per week. Goran estimates parameter M to be the mean of the sample 1.76. He calculates the expected frequencies for sightings per week in the 50 weeks after the first day of September. These are shown to 2 decimal places in the following table. Find the value of J and K. For this J, we got to use Poisson PDF 1.764, then times 50 to get this expected frequency. For this K, we will use Poisson CDF 1.76. It should be at least 5. So 5 is the lower bound. 9999 is the upper bound. Then times 50. 4. Enter. Enter. Then times 50. 3.44. Lower bound is 5. Upper bound 9999. enter. Then times 50. Answer is 1.68. State a reason why Goring should combine groups to conduct his significance test. Because the expected frequencies are less than 5. When we add these two expected frequency, we can get greater than 5. So we only need to combine these two together. Let's go back over here. We need to combine these together. This is the table after we regrouped the data. Write down the degree of freedom. Let's check how many observed data we have. 1, 2, 3, 4, 5. So df equals 5 minus 1 for simple cases. Since in this Poisson distribution, 1.76 is estimated from the data, we need to minus 1 equals 3. So put this into spreadsheet to work out this p-value. After you put data into this spreadsheet, F for observed frequency, FE for expected frequency. Go to menu, go to 4. Go to 4 again. Go to chi-square GOF test 7. Observed frequency is F. Expected frequency is FE. Degree of freedom is 3. We got chi-square equals 0.105. P-value equals 0.991. G. State the conclusion of the test. Justify your answer. Since 0.991 greater than 0.05. Fail to reject HO, which means the data can be modeled by a Poisson distribution. Enough evidence to suggest that the data can be modeled by a Poisson distribution.